A proportion is two ratios that are said to be equal to each other, right? And if you can understand that, the next 4 pages will be very, very simple. You can look, I mean, if it's easier, sometimes I personally like it this way. 475, when x is 60, we don't know what y is, and when y is 12, we're trying to figure out what x is, right? So, think about it. What is happening to every x value to get to y? So 4 times what particular number? 7.5. 16 times what particular number? 7.5. And then, in this case, what multiplied, something multiplied, or if you go backwards, the 12 divided by that factor is equal to your x value. So one way of doing this is finding, you can just simply take a calculator. If you think about it, is 4 times something gave me 7.5, because that's what it's saying, right? And this something, right, is your constant of proportionality. Right, because it's going to be that same constant. The 60 is going to be multiplied by the same factor, and in this case, the 12, because we're going backwards, we're going to divide 12 by that number. So, how do I find this number? Well, find the constant of proportionality. You take a point, any of these points. Well, in this case, we can only use 4 and 75 for common 7.5 because it's the only point that I know. And if you take that and substitute, we get y 7.5. And x is 4. Now you can leave it like this, but let's see if we can make that a little bit prettier. And that equals to k equals 1.875. So that's what this is saying. So to go from x to get to y, we multiply by 1.75. And then the 60 likewise multiplied by 1.875. And just the 12, we're going backwards, it's going to be divided by 1.875. And that's your relationship, right? So let's do 60. 60 times 1.875, we should get 112.5. And then the 12, right? So something times 1.875 equals 12, we just got to divide. And you get 6.4. Now, again, you didn't have to do that. I created a table. But if you can see it this way too, it's fine. Okay. Which one has a better deal? Well, if you want a better deal, we have to find the unit rate, right? So that's where the unit rate comes really handy. So what do we have here? 349. So let me write each of them as a fraction. I get 18 ounces. The second one is 4.99, and we're comparing it per ounce, right? If you want to compare it per dollar, you could have done that too, but I guess I'm just so used to finding where the y is your dependent value. And then 6.79 for 40 ounces. So for each of these, I'm going to change this to a unit rate. So that's 1 ounce worth. So again, you can, if you remember your 6th grade, right, you dealt with this. 18 divided by something gave you 1, so we divide that by 18, and you divide this by 18. And 3.49 divided by 18, 0.18 I should say. We're going to round this to 19, 3.49 divided by, what? 3.49 divided by 18, is equal to 0.19. I'm going to go 3 decimal places, just in case. Here, again, I'm going to change this to 1 ounce. We're going to divide this by 28, and we're going to divide the top by 28. 4.99 divided by 28 equals something, 0.178. I'm going to have 3 decimal places again. And the last one, I'm going to divide top and bottom by 40. So 1 ounce is 6.79 divided by 40, which gives us, if I round this to the nearest thousandth, it's give me this. So the better deal is this guy over here, because each ounce is 17 cents. Okay. All right, so again, use the table below to find how many miles are driven in 15 hours. Well, let's extend my table. This is the same, almost like the first problem we just did. So we have 15 hours. Again, let me write it this way. time will always be your independent value, so we'll always be on the x-axis. So from 4, I get 7. Sorry, from 4 I get 48. From 7 I get 84, and then 15 we're missing, right? So this one is simpler. It's pretty straightforward. You can easily see that the constant proportionality again is 12, but again, let's do this. K equals y over x. You can pick either the 4 and 48 or the 7 and 84. It doesn't matter which one you choose because you have both. So let's pick 48 and 4. 48 and 4, K equals 12. So, which also happens to be your unit rate. Right, so 15 times 12. So let me add on to that. So this is times 12, this is times 12, and this is what will be times 12. So 15 times 12 equals 180. So to continue a little bit here, let me just draw a graph here. So we had, and again, 4 and 48, 7 and 84, yeah, 15 and 180. And when you get to 1, guess what? 1 would be 1 will be 12, which also happens to be your unit rate. So this point right here, I mean, and then if you get the other points, right, you would be able to draw a straight line going through the origin, and 1 and 12, right, would be your unit rate. Unit rate, and this 12 here is your constant of proportionality. Right, it's what you're multiplying every x value to get to the y value. Every 5 minutes, a shoe factory produces 100 pairs of sneakers. How much will it produce in a day? Okay, so 120 sneakers. I'll write that down, and let's write our relationship here in 5 minutes. Now notice that 1 hour, or 1 hour has 60 minutes, right? 1 hour has 60 minutes, but in a day we have 24 hours. We're going to multiply 60 times 24, and we get that 24 hours has 1,440. Let me write my units. If you always write your units, you will never have to guess where to put the values because it's labeled for you. So, so many ways you can do this. Right? So you can put x, we could have cross multiplied. Let's do it that way. If we cross multiply, we get 5 times x, which is 5x. 120, because we have a calculator, it doesn't really matter. It's, what is this, 172,800. We're going to divide both sides by 5. And x equals 34,560. That's how many sneakers it will produce in a day. So the only two proportion find the unit rate align the equation line. So A is proportional, right? Straight line goes through the origin. Can I find the unit rate? Well, if I find the unit rate would be, so let me put it, when you don't have numbers, fill it in. So this is 0, this would be 1, 3, 4, 5, 6, we don't need that many. So A is proportional, look at the A line, the unit rate would be, where X is 1, Y is 3. So here, for letter A, the point 1, 3 is your unit rate. And 3, ladies and gentlemen, is our constant proportionality. Right? Now, if you gather a few more points, and just to prove it to you guys, well, we have 1, x equals 1, y equals 3. If x equals 2, look at that. Y equals 6. If x equals 3, we have y equals 9. So notice that it's times 3, times 3, times 3. And there you go. So once you find the unit rate, you find the constant proportionality, and then you can use that to create your equation, right? It's the equation of this line is y equals kx, or y equals 3x. Ta-da! C is this one over here, and again, C is proportional. C is proportional. The unit rate is where 1 and then, but I don't know what it is because I can't tell from the graphs. It's 1 comma something. Well, if I don't know what 1 is, let me find another point which I can actually see. Well, I think this is 4 and 2. So let me create a table here. When x is 4, y is 2, do I have any other point that I can actually see? Look at this. So x is 4, 6 and 3. 7, no, 8 and 4. So already that sort of gives you a clue as to what our constant proportionality is going to be. Well, if you take any of those points, doesn't matter which one, and you plug it in, k equals y over x. Well, let's take 6 and 3 just to be different. Y is 3, x is 6, and that equals 2 1/2. So what's happening to every x to get to y? It's 4 times 1/2, 6 times 1/2, 8 times 1/2, and that gets us our y value. So constant proportionality is this point right here. And it's 1 comma 1/2 or 0.5. So we can use that, right? So 1 and 1/2 comma 1/2, and the equation of the line is going to be 1 half times x, or if you want to write it as 1 x over 2, or if you want to write it as 1 0.5x. They are the same thing. Okay, so see how that unit rate comes in handy. 6. Then why do I feel like we did all these? Again, push-ups, 5 minutes, and then the other person was 120 push-ups in 12 minutes. Right, so let's find the unit rate. Change this to 1 minute, change this to 1 minute. You can cross multiply, but I'm pretty sure you can see that it's very easy to just divide by 5, so therefore divide by 5 on top, and you get 10. So this person can do 10 push-ups in 1 minute. Jeez. And this one, divide by 12, top divided by 12, so we get 12, 120 divided by 12 is, 10 push-ups. So in this case, it's a tie. It's also the same amount of push-ups per minute. 7. Now this is called a complex fraction. It's just a fraction of a fraction, a fraction of a fraction. But the idea is the same, right? We still want to, in this case, how do we know which one to put in the denominator? Well, because it says here, miles per hour. So how many miles in an hour? So 3/5 of a mile in 2/7 of an hour. We want to change this, right? So again, we're finding its equivalent, the equivalent ratio where just the bottom is 1, right? So again, you could have cross multiplied this. I don't think you would have liked it too much. Or going this way, how did this 2/7 become 1? Well, we're going to divide that by 2/7. Now, dividing it by 2/7 is the same thing as multiplying by the reciprocal, which is 7 over 2, right? Isn't that what division is? So at the bottom, this all simplifies to 1, right? 2 divided by 2 is 1, 7 divided by 7 is 1, so we have left with a bunch of 1s, so that's 1. On top, can't simplify anything, so it's 3 times 7, which is 21 over 10. Or if you wanted to, there. Either or. Right, so far nothing you haven't seen. A small baby can crawl 2/5 of a mile in 45 minutes. Right, so again, write your units, write it as a fraction. I think it's preferable. For 45 minutes, what is it of an hour? Well, you could have written 45 out of 60, or in this case, 3/4 of an hour. Same thing. We want to change this to 1 hour. Now, how does 3/4 become 1? Well, times the reciprocal, which is the same thing as divided, right? We're dividing top and bottom by 3/4, but we're going to take it one step further and just write that it's the same thing as multiplying by the reciprocal. So there you go. All that simplifies to 1. On the top, yeah, just 8 over 27 miles. The baby can crawl all this in 1 hour. Explain what the 0.150 represents. Well, the 0.150 is the unit rate. Okay. That represents $50 in 1 hour. The 50 is our constant of proportionality. Right? We can also, which is k, right? The constant proportionality, which is k, and so we can use that 50 and write our equation. That equation becomes y equals 50x. Now, understand what that means. So if you take all these x values, 1, 2, 3, 4, 5, 6, 7, I'll write them down here. 1, 2, 3, 4, 5, 6, 7. How do I get, what is their y counterpart here? So look at this. When it's 1, what is this? 50. When it's 2 is 100. When it's 3 is 150. When it's 4 is 200. When it's 5 is 250, 300, 350. So what are you doing to every x value, right? Every x value. So every x value that you come here and plug in instead of x, you end up multiplying by 50. So it's times, change colors here, right? Times 50, times 50, times 50. That's your constant proportionality, right? Times 50, 50, etc. And they should have put an arrow here. 10 right here. How much does she need to make 8 batches? So 1 3/4 of cups of sugar makes 1 batch. How much sugar does she need to make 8 batches? Really? Well, here's 8 batches. Again, we're going to set up a proportion. I'll put sugar over the top here. Our units are the same. Now, geez, times 8, and this would be times 8. You can cross multiply. So 1 3/4, it's the same thing as 4 times 1 is 4, plus 3 is 7 over 4, right? And I multiply that by 8. That simplifies, and I get 14 cups of sugar makes 8 batches. 11. Can you notice, or can you tell that k is going to be important for us? So, unit rate, right here. Well, I'm at the 1 right here. That's my unit rate. We're at 1, right? When the x value equals 1 and it meets its corresponding y value. So there it is. There's my unit rate. Can I tell you what it is? No idea. Well, because I can't measure that. But I create a table. You don't have to create a table, but I'm creating a table just to show you, pick values that we can actually measure. When x is 10, I can measure that. Y is, and what's this value? 15. Let's pick a few more. When x is 20, y is 30. When x is 30, y is 45. Right? I'll pick one more. When x is 40, y equals 60. So these are points that I can measure on the graph. Now, the unit rate here, I can't tell you. I know it's 1 and something. That's something that I have to look for, and that something is our constant proportionality. So all these points here, they will all have the same constant proportionality because this is a relation proportionate shift, and we know that because it's a straight line and it's going through 0, 0. So k, y over x, pick any of these. Just to be different, let's pick these guys here. K equals 45 over 30. And what's that going to equal? 1.5. Right? If you can leave it as a fraction. 1.5 is fine. So notice that what's happening to every x? Well, we're multiplying by 1.5 times 1.5, and it works, right? You should check times 1.5. So every x value is being multiplied by 1.5. What's our equation of the line? Y equals 1.5x, right? To find the value of y, what do we have to do? We have to multiply every x value by 1.5. 12. Gas is probably $2.45 per gallon. Well, we know it's proportional because when you go to that gas station, they're not going to charge you $1 for the $2.45 for the first gallon, and then $2.55 for the second gallon, and $3.85 for the third gallon. It's always the same price per gallon, so it's a constant relationship. So let me write this. $2.45 for 1 gallon. What is this called? This is called our unit rate, right? And who's our K? K is this guy on top. 245 is our constant proportionality, right? So again, you don't have to create a table. I'm showing you that if I have 1 gallon, I pay $2.45. If I have 2 gallons, I'm going to pay $4.90. If I have 3 gallons, I have no idea. We're going to pay $7.35, and so on and so on. It's always times 245 times 245 to 7.5. So we know K is our constant proportionality, and if I know K, you know the equation. Y equals Kx. But they didn't want this in this form. They actually wanted you to use not Y, but instead of Y, remember, let me write this down. This is our X, this is our input, also known as our independent. Your Y axis is here, which is also known as our output, and our dependent. Right, so in this case, writing the equation phi C, the total cost. Well, Y represents the total cost that we spent in this case, right? All that money. And then C equals 2.45 times G. Same thing, except that I guess they wanted in the context of the story. Okay, C for cost and G for gallons. So, this one we haven't done too much of. Or actually, we haven't done anything to this. Let me write the relationship that's given to us. We know that 4/7 cup of bananas are needed along with 1 3/5 cups of blueberries, right, to make a smoothie. So we're making a smoothie. So if we make one single smoothie, think about that for a second. If I were to make one single smoothie, I would use 4/7 of a banana and 1 3/5 cups of blueberries, correct? Now, how much did I use? Well, in cups, it'd be 4/7. Oops. 4/7 plus 1 3/5. That means I used 2 6/35 cups of fruits. You okay? So far so good? Right, so this is my total. Now the question is saying, how much blueberries needed to use 1 cup of banana? Okay. You know what? Let me do the latter half, because that's what I'm setting it for, the latter half, the second half. So how many bananas are needed if a total of 25 cups of fruits were used? Well, I have this relationship, and on the other side, I'm going to write total blueberries, because this is a proportional relationship. Bananas. But we're saying here that I used 25 cups, combined the 25 cups total fruits. That includes bananas and blueberries. So if you use 25 cups, how much of it was blueberry and how much was bananas? Now, this one, how do I get there? That's what you're going to look for. How does 2 6/35 times, because it was increased by a certain factor, right? We multiplied by a certain number to 25. So if you can find that number, you're golden. So to find the number, obviously, we're going to go 25. I'm going to divide that by 2 6/35. So 25 divided by 2. Sorry guys, 2, 6, and 35. If you do that, you're going to get this is 1139 over 76. Which means everything else is also going to be times the same factor. So let's multiply that times 4/7 as far as simplify, so we get 6 and 11/19 out of the 25 cups, 6 and 11/19 for blueberries. And then if you multiply 4/7 times, what is that, 1139 over 76. Sorry. Where is it? 1139 over 76. We're gonna get, simplify, get 7, 19 over 28. Oh, something's wrong here. Did I multiply something wrong? Yeah, I multiplied the first one wrong, so it's 1 3/5 times 1139 over 76. This should have been, I apologize, it should have been 18 and something. 18 simp 18 22 over 23. Let me just make sure I do this correct. So we get 7 19 over 28 plus 18 22 over 23. These are not pretty numbers, and we get 26. Okay. Give me a second. 4/7. Did I add this correct? So let me just add plus 5th. No, that's correct. So far so good. So this column here is correct. So let me just divide this correctly again. 25 divided by 2 and 6 over 35. God, I hope you have a better calculator. That's 11, 39, 76. So far so good. Let me multiply this again. 1 3/5 times 11, 39 over 76. Enter. And I got 18, 9 over 18, sorry, I apologize, 18, this is 18, 8 over 19. Okay, so let's see if I do the top correctly. Let's multiply 4/7 times 11, 39 over 76. And I get 6/11 over 19. Okay, that's a better answer. So I just used the calculator incorrectly. So, and again, just to double check, if you add these two, 11 plus 8 is 19. So that's 19 over 19, which is 1, right? 18 plus 6 is 24, plus that whole number of 1 gives us a total of 25. So there is your answer. Right? So that's this part over here, the second question. How many bananas are necessary? Here's 6 and 11/19 of a banana. Now the first part is how much blueberry is needed if Taylor uses 1 cup of banana as well. The unit rate here is 1 3/5 of blueberries. She uses 4/7 cups of bananas. Now, if she uses 1 cup of banana, how much blueberry does she need? And that's what we're looking again. So times the reciprocal, which means I multiply times the reciprocal on top. Everything at the bottom simplifies to 1. On the top, you get 1 3/5. 1 3 5 times 7 over 4. And we get simplified 2 4/5. So we're going to need 2 4/5 cups of blueberries every time we use 1 whole banana. All right, got a little messy. Apologies. All right. Sometimes the unit rate comes in handy, like this one. So 18 planes in 3/5 of an hour. Let's write 3/5 of an hour. Let's find out how many planes you can make in 1 hour, right? So find the unit rate. In this case, we're going to multiply that by 5/3 and multiply this by 5/3. 18 divided by 3 is 6, so she can make 30 planes in an hour. So that's my unit rate. Look how much easier it is now that I have unit rate to find anything. So now she wants to know, we want to know how many planes are making 2 hours and 50 minutes. Well, 2 hours and 50 minutes is written as 2 hours and 1/4, 2 and 1/4 of an hour, right? Or 2 and 15 over 60, however you want it. So how did that one become that? Well, obviously times 2 and 1/4, which means I'm going to take the top one and multiply that by 2 and 1/4. So 30 times 2.25, which is probably easier. She can make 67.5 airplanes, but in the context of this story, we're just going to say she's going to make 68 airplanes. Okay, so 1/6 cup of jam for every 3 cups of peanut butter. How much peanut butter is needed if you use 1 cup of jam? So let's find the unit rate in terms of 1 cup of jam. So we have 3/5 cups of peanuts every time for every 1/6 cup of jam. That's our story. Now, if we use 1 cup of jam, how much peanuts would we need? Well, what is this? 1/6. How does 1/6 become 1? Well, times the reciprocal, which is 6 over 1, times the reciprocal, which is 6 over 1. Well, that's easy. On the top, we got 18 over 5, or if you want to write it as 3 3/5. So 3 3/5 cups of peanuts for every 1 cup of jam. How many cups of peanut butter are needed if 18 cups in total were used? Okay, so we can use the unit rate as well. So what we're going to do is write it bigger first of all. So 18 over 5 cups of peanut butter, right? That was the answer from the previous one. For every 1 cup of jam. So that means that currently total amount in 18 over 5 is the same thing as 3 3/5. So the total amount, cups-wise, is 4 3/5. That's what we have. So every time you use, maybe I should change this 18 over 5 to 3 3/5. Probably easier for you to see it. There we go. Right? So if you use 3 3/5 cup of peanuts, you're going to need 1 cup of jam. So the total number of cups we use right now is 4 3/5. But what if there's a large group of people coming and we use a total of 18 cups in total? How much of that was jam? How much of that was peanut butter? And that's our task. Well, how did that happen? Well, 4 3/5 times what is 18? We can just simply divide. And our mystery number is times 321 over 23, which is going to be the same thing here and the same thing here. So let's just multiply that times 3 3/5. We get 14 and 2 over 23, which in this one should be 3 and 21 over 23, right? So, which is exactly what it is, because 1 times 3, 21, 23 is that, and if you add them up, you get 18. So we're good. The floor of the living room was carpeted. Okay, the total cost to carpet the living room was $845.25. What was the price of carpet per square foot? Well, we need to find the total. The area of this room is 160 square feet, right? Because it's 16 times 10. So it says here, our information says that you paid $845.25 for 1 square foot. No, sorry, not for 1 square foot, for the whole room, and this whole room we just found out was 160 square feet. So what we need to know is how much do we pay for one of these, right? One foot by 1 foot area. So we're gonna divide this by 160, right? I'm gonna divide the top by 160. This one is straightforward. 845.25 divided by 160. Enter. We're gonna round this to $5.28. Okay. Table below shows a single point that is on the line that shows a proportional relationship. Okay. Which of the following points could be on the line? Well, 2 ways to do this. Let's take the easy way out. First one, if it's proportional, you know it's going to go through 0, 0, and it's going to go to that point. Remember, to create a line, you need 2 points. We have 1 point. Right? We need 2 points to create a line. I have point A, but the other point I got because they told me it was proportional. If it's proportional, the other point is 0, 0. So, join that. Okay. So that's what the line looks like. Now, which of these points are on the line? Well, it's 5, 1 on the line. 1, 2, 3, 4, 5. Go up 1. No. It's 8, 8 on the line. 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. Look at that. This one is. Check. It's 2 and 1 on the line. 1, 2. 1 up. Nope. 3 and 5. 3 to the right. 5 top. No. Now, so that's one way. Another way is, if you want to create a table, we had the points 5, 1. Let me erase them so we can see them. We had the points 5 and 1. We had the points 8 and 8. We had the points 2 and 1. And you had the points 3 and 5. And we actually had our main point, A and A, which is 1, 2, 3, 4, 5, 6, 7, 8. And go 8, right, which is this point over here. Now, if, the other point I meant to say was point A. Point A was 1, 2, 3, 4, 5, 6, and then 6 up. We had this point here, which was key for everybody, point 6 and 6. So this one, point A, using point A, which is at 6 and 6, let's find the constant proportionality. Well, k equals y for x. In this case, it's just 6 over 6, which equals 1, right? So what does that mean? It means that the equation of the line is y equals kx, y equals, well, k is 1, 1x. We don't need to write that 1 because we know it's invisible, right? There's a 1 here, whether you see it or not, right? So that actually says y equals x. So if you plug it in, right? So if you plug this particular point, 6 and 6, if you apply 6 for x and y for x, you get 6 equals 6. Is that true? Yes, it is. For this one, if you plug it into the equation y equals x, you get 8 equals 8. Is that true? Yes, it is. But if you plug 5 and 1, so remember, this is the equation. If I take the point 5 and 1, will that make the equation true? Well, this is my x value, this is my y. So you're actually writing 1 equals 5, which is definitely not true. So remember, every point on this line that exists on any point, right, even the ones we can't measure right now, but any point on this line will satisfy our equation and make the equation true. Okay. How are we doing? No, almost, yeah, sort of. What's a better buy? What's the difference? Okay, in cost. So let's do the first one. We're paying 96 cents for 12 ounces. Let's find the unit rate. Well, 1 ounce. Okay. So we're going to divide this by 12. Divide the top by 12. 0.96 divided by 12-ish. 0.96 divided by, oh my god. Divided by 12 equals 8 cents. The second one is $1.12, and we get 16 ounces. You want to change that to 1 ounce. You could cross multiply, or just find that relationship. Is divide by 16, right? We're going to divide the top by 16. 1.12 divided by 16 equals 7 cents. So this is the better deal. $19. Carlos paid $112.50 for 9 books. Find K. So if they're asking you to find K, they're telling you it's a proportional relationship. Every single book costs the same price. Write an equation to show the relationship between the total costs and the number of books, right? The total cost meaning Y and the number of books being X. Well, so if you think about it, right? If you draw, books will be your independent, so that would be here. They're telling you that at 9 books, this guy here paid 100. This is the cost, and this would be 112.5. That's the point right here. 9 books, $112.50. That would be this point. Right. So we create a table. Not that table. Create a table. X, Y values. This would be 9, and this would be 112.5. It's because it's what do you call constant, whether I write 8, 5, 4, whatever I multiplied 9 by to get 112.5, I'm going to repeat the same process, 8, 5, 4, or any number of books. And this represents books, and this represents cost. Is that what you're looking? Cost, yeah. So let's find K. Well, K equals Y over X. We're going to divide 112.5 divided by 9. Divided by 9, and that's going to give us $12.50. So our constant of proportionality is 12.5. And if we know that, I can come to this graph and tell you that the unit rate, when I buy one single book, is going to cost me $12.50. And that's the point right here. In this point, 1, 12.5 is our unit rate, and the equation of this line, right? So sorry, it should be 0. If the equation is line, it's going to call y. It's going to be called y equals 12.5x. Right. Every x value represents the number of books you're buying. It's going to be multiplied by 12.50. So every book in that store apparently is $12.50. Is it proportional? So it's 2 times whatever, 5 times whatever, and 7 times whatever. That same number present, right? Is the constant proportionality the same? Well, there's no other way but to try it out. So let's try the first one. 63 divided by 2. The second one would be 112.5 divided by 5, and the last one 145.50, right? So we're finding y over x, y over x, and y over x. Well, let's see what that equals to. 63 divided by 2, that one is a little simpler. It's 31.5. 112.5 times divided by 5 is 22.5. And then the last one, 145.5 divided by 7 is 20 point with some ugly decimal. Let's leave it like this. So notice that our constant proportionality is not the same. Here, x is times, like I wrote, 31.5. Here's x is times 22.5, and here is x times 20.76. There's no way this is a proportional relationship because that line would not go through 0. Okay. Sam paid $5.30 for 5 apples. Find K, write the equation to represent the proportional relationship. Okay, so you don't have a graph, but nothing stops you from drawing one. This is saying that here, 5 apples, this is apples, or x, and this is the cost, or y. And you paid $5.30. And there's your point. Now, if it's proportional, they're saying that, right? Right? What is, we're looking for this right here. 1 and question mark. So, we have a couple of points. We have x, y. We have that when she bought 5 apples, she paid $5.30. When it's 1 apple, how much will she pay? Well, we can easily find that, right? So let's do that. So K, our constant proportionality is $5.30 over 5. K equals $1.06. So each apple costs $1.06. So when you buy 1 apple, how much are you gonna pay? $1.06 in here. There's my unit rate, and there's my constant proportionality. So now that I have the unit rate and the constant proportionality, I can write the equation. Remember, the equation comes in the form of y equals x, y equals k times x, and y equals, again, 106 times however many apples you buy. 27. Ooh, this one. Okay, so is an equilateral triangle means all the sides are the same, right? I'll put a little symbol. This, and these are all equilateral, all the same measurement. It's proportional to its perimeter. Right? An equation to describe P, the perimeter, in relationship to S, the side of the equilateral triangle. Okay, so we have no numbers to begin with, but we can create one. We need a table. Let's pretend this was 1. If that was 1, it means this is 1 and this is 1. So when x is 1, right, when there's x will be the side, and y is going to be the perimeter. And when the side of this triangle is 1, all the other sides will be 1. So that means the perimeter is 3 because we add them all up. When the side is 2, so let me erase, come back. So anytime you don't have numbers, plug it in, put some numbers, pick easy ones. If the sides are now 2, what's my perimeter? 6. Okay, is that enough information? Let's do maybe 1 or 2 more. If the side of this triangle is 3, it means this is 3 and this is 3. What happens to my perimeter? 9. Let's do 1 more. If the side of my triangle is 4, it means that this guy is 4 and this guy is 4, and my perimeter is 12. That's enough. Can you find the constant proportionality? Can you find what number was multiplied by 1 to give you 3, by 2, by 3, by 4? Well, this one is obvious, right? And nevertheless, I'll do this. Pick any of these values. 4 and 12, 9 and 3, right? 6 and 2. So if you pick any of these values, let's pick this one. You get y is 6, x equals 2, and that just gives you 3. So the constant proportionality is 3. Now that means that the equation of our line is going to be y equals 3x. What is happening to each of these x values? Being multiplied by 3. Okay. Last question. What is this? Which table shows the proportional relationship? So look at your x values, and whatever is happening to your x values must happen with all of them. So this is times 3. This is times 3. So far, so good. But 7 times is times 4. So this table is gone. Right, the constant proportionality K is not the same for all of them. Let's do this one. 1, how does 1 become 5? Times 5 times 5 times 4 times 4. So, because they're all different, not they're all different, but once we have one that's different, we know it's already not proportional. Okay, this one times 4 times 4 times 4, but it's not times 4 here, so this one is gone as well. 3 to 9 is times 3. 5 to 15 is times 3 times 3 times 3. So the only one that's proportional is this one. And it's times 3 times 3 times 3, which makes my equation y equals 3 times x. All right, so